Lesson 24 is all about solving decimal equations. So our two-step method of using inverse operations and working in reverse order is now going to be applied to problems with decimals. So there's a couple key strategies that you need to make sure that you know in order to take on this challenge. The first key strategy comes from example 1, and we're going to take that into account for letter A and letter B. When you're working with decimals, sometimes you wish you weren't working with decimals. I know Mr. Sheen thinks like that all the time. I want to eliminate those decimals. I wonder if there's a way in which you could move the decimal place. Well, there is. If you multiply by a power of 10 to the entire equation, then you can actually move each of those decimal places and it doesn't change anything in the equation. It's kind of like our properties of equality. If you do something to both sides of the equation, it doesn't change the equation, it just alters what is there for you to actually simplify. In this case, if you multiply by the appropriate power of 10, you can change each of the terms in the equation to remove those decimals. Now, what you need to make sure that you're going to do is pick out the right power of 10 to multiply. What I always like to think about is what is the greatest number of decimal places in terms of the value of decimal places that one of the terms has. I'll pick that greatest number and then multiply that power of 10 by every decimal place or every number in that equation. Look at example A. You got 0.25 plus 0.18y equals 0.97. So all of these have two decimal places. It means to multiply by a power of 10 appropriate to move that decimal place twice, I have to go to the same number of decimal places, and my power of 10 has to have that many zeros. So my power of 10s are 10, 100, 1,000, 10,000, and so on. The appropriate one is going to have the same number of zeros. So if I need to multiply by two decimal places or move that decimal place two places to the right, I need to multiply by 100. In this case, I'm going to rewrite this, multiply by 100, multiply by 100, multiply by 100. Now the only thing that changes is where those decimal places go. They move to the right, move to the right, and move to the right two spaces. Now I can rewrite the entire expression without those decimal places. 0.25 turns into 25, 0.18 turns into 18y, and 0.97 turns into 97. Now I'm back in lesson 23, solving two-step equations without having to worry about decimals. I'm going to use the reverse order and inverse operations to get that done. Here I have positive 27 or plus 27. I'm going to subtract 25 from both sides. This is my first step. 7 and 5 is 2, 9 and 2 is 7, and I get 18y equals 72. Now I'm going to take and I'm going to divide by 18 on both sides. Divide by 18, divide by 18. 18 and 18 is 36. 36 and 36 is 72, so y equals 4. Notice how I eliminate the decimal by picking the appropriate power of 10, and then I can go ahead and solve for that overall value. Take a look at letter B. Here you've got 0.05, so I've got two decimal places. 0.5 only has one decimal place, and 0.15 has two. So just because there's a difference between having two decimal places in both of these terms and one decimal place here doesn't mean that I change that power of 10 and only multiply by 10 here and not 100 here. I can multiply by the largest power that I need to solve and simplify all of those throughout. So again, I've got two decimal places as my largest number of decimal places that I need to move. I'm going to multiply by 100 times 100 times 100 times 100. Now in these two terms that have two decimal places, it just gets moved to the end of that number, and this becomes 5 equals, and then here, 15g. When I have two decimal places to be moved and there's only one decimal place, it goes to the next space afterwards, and then there I fill in an extra 0. So I would have 50 minus 15g. Now I can go about solving this with my reverse order and inverse operations. I got 50 minus 15g. I'm going to subtract 50 from this side, subtract 50 from this side. I get 5 minus 50, or 50 minus 5, which is going to be 45. That's going to turn into a negative value. And I get negative 15g left for my second step. First step, second step. Here I'm going to divide. If I divide by 15, negative 15 on this side, that'll cancel out. I divide by negative 15 on the other side. Negative 45 divided by negative 15. Two negatives makes a positive. In this case, g equals 3. Again, eliminated my decimals by picking the appropriate power of 10, multiplying to get rid of those decimals. Well, it's not always appropriate to have to use that. You don't actually need to do that if you don't want to. That's just one method to maybe make it easier for you. In letter C, we're going to look at it without solving with that power 10 and just go about adding and subtracting and multiplying and dividing with those decimals. A couple things to remember. When you're adding and subtracting, you need to line up your decimal places. When you're multiplying or dividing, you need to make sure that you keep track of the number of decimal places and add that appropriately to where that decimal goes at the end of your calculation. Letter C, you've got negative 0.5n plus 1.4 equals 8.9. Now I can just go about solving this with my reverse order and inverse operations and not worry about those decimals if I'm good at using addition and subtraction with my decimals. So I'll minus 1.4, minus 1.4. Notice I line up my decimal. Draw that line for my first step. 9 minus 4 is 5. 8 minus 1 is 7. And I get 7.5 equals negative 0.5n. Now I need to divide because there's multiplication here. The opposite operation would be negative 0.5, negative 0.5, and I can go about dividing to see how many 0.5s go into 7.5. 7.5 divided by 0.5. Now you've probably learned to solve a division problem with this in terms of moving your values over, which is 5 going into 75. How many times does 5 go into 75? 5 goes into 50 10 times, into 75, which is another 25 5 times, so it's going to be a total of 15. N equals 15. Again, you can plug that value back in to check to see if you've got that done correctly. For letter D, you've got 0.6 of 24 is what number? In example 3 in your lesson 24, it says finding parts of a number with decimals. Decimals and percentages are really closely related in this way, and we can use of as a way in which you're multiplying a decimal value, which is the simplified form of a percent, to find how much of that value there is. In this example, you're taking 0.06 of 24 is what number? To think about that in a mathematical expression, I want to write it out first in the way it's read. 0.6 of 24 equals what number, and I use n for what number, and then I say of actually means multiply, so I rewrote that right here to represent multiplication. Now I'm going to multiply 24 times 0.6. 6 times 4 is 24, carry the 2. 6 times 2 is 12, plus 2 is 14. I have to remember I have one decimal place, so that goes there, 14.4. So 0.6, which is actually equal to 60%, 16% of 24 is what number? Say you had some type of assignment in class and you got 14.4 out of 24 correct, your overall percentage would be a 60%. Another way to represent that is in the form of a decimal. So anytime you're given a decimal problem to find the part of a number, you're simply multiplying by that decimal to figure out what that value is. Of means multiply, so you plug that in and then rewrite the expression as a multiplication problem, just like you see here. The last of our practice problems comes from letter E, in which it's giving you an example of highway mileage. Use the diagram. The distance from town A to town C is 52.8 kilometers. What's the distance from town B to town C? So here you've got a value that's given and a value that is unknown. Use the diagram. Distance from town A to town C is 52.8 kilometers. What's the distance from town B to town C? So you don't know what the distance is. You know what the total is from A to C is 52.8 kilometers. And that total is actually equal to the variables that are given. You've got x and 2x. If I add those together, I get that total value. Now it's asking us what is the value of B to C, which is 2x. Well, to solve that, I've got to try and eliminate these variables or get the variable by itself, and then I can go back and plug it in. Here I would add these together because this is like saying 2x plus 1x, so 52.8 equals 3x. If I divide by 3, let's do the math. 52.8 divided by 3, 3 goes into 5 once, 3 times 1 is 3, 5 minus 3 is 2, bring down the 2, 3 goes into 22, 7, 3 times 7 is 21, subtract 1, bring the 8, 3 goes into 18 6 times, 17.6 is equal to x. So one of those values is 17.6, and then the distance from B to C is actually 2x. So let's rewrite this over here. 2x equals 17.6 times 2. If I multiply that by 2, 6 times 2 is 12, carry the 1. 7 times 2 is 14, plus 1 is 5, 15, carry the 1. 1 times 2 is 2, plus 1 is 3. The distance from 2x, or the distance from B to C, is actually 35.2 miles, or kilometers in this case. That's the appropriate measurement. Hope that helps with solving decimal equations in that two-step method. God's blessings on your assignment.